Can you say that louder into the microphone, please?
I said flowers are pretty.
Ah, you're a liar. You're a lying liar.
You're right. They're just okay.
Yeah. I too have used the Logitech software. In fact, I still have it loaded, and all it does is annoy me as far as like every once in a while it pops up and it's like, hey, I need to be updated. And I'm like, can't you just do that? Like, you don't have to ask my permission.
Just go. Why are you always preparing? Just go.
Just go. I don't think I actually need the software at this point because I don't use that camera for anything except logging into my computer
Oh, just for hello.
for Windows Hello, which is why I upgraded from, was it the 920 or whatever?
Yeah, because only the whatchamacallit respects the who's and what's it.
Yeah, it needs that additional infrared or something to be able to capture that it's really a human being and not a photo, even though you can probably still fool it, but allegedly it's better. Um, so yeah, that's really the only thing I use that camera for. I just have it off to the side specifically for that. And any other time, I guess it's just a webcam hooked up to my computer that's doing nothing.
Probably spying on you.
Oh yeah, absolutely. That's the other reason I kind of want to uninstall the Logitech software because I don't entirely trust their software supply chain. Does that sound harsh? I don't think it sounds harsh.
I mean, it sounds paranoid, which excellent.
Is it though? I mean, do you really think that their main priority in life is securing the software supply chain for their various random apps and stuff? I don't think so. I think they're concerned with just making a more expensive webcam they can somehow convince you to buy. And I think they got into audio equipment too. I think there's like Logitech microphones now for the podcaster who wants it all, but not very good.
That would not surprise me. Their mouses are excellent.
Mm-hmm. Which do not require software. I have the Logitech Marathon mouse. I think it's called the Marathon mouse. I don't know. It's cool though because it's Bluetooth and it can be connected up to 3 devices. So I
Right.
can
So you can use it for like 2 different computers and also the NSA.
Yes, absolutely.
Excellent.
Not the SNES because that doesn't work with a mouse as far as I can tell. I've tried, but I just can't make Super Mario jump with it. It doesn't work.
He's just regular Mario if he can't jump.
Wow, that's really... Let's start the show. Hello, alleged human, and welcome to the Chaos Lever Podcast. My name is Ned, and I'm definitely not a robot. I am taking multiple medications for seasonal allergies that my aging form has somehow miraculously developed. Hooray! What could be more human? Doctors and medicine and entropy and the heat death of the universe, you know? Shared human experiences, am I right? With me is Chris, who is also here.
I mean, advantage, the heat death of the universe doesn't happen for another 14 trillion years, give or take a couple billion.
I mean, I definitely won't be there to see it, and neither will you, fellow human.
I'm frightened.
Do you have allergies like
Oh
pollen?
yeah.
Yeah?
Oh yeah. My middle name, in fact, is Allergy.
Wow, that's very perceptive or interesting that your parents chose that. Or was that self-imposed?
No, I think they planned ahead.
They just know. I
Yeah.
gotcha.
My mom was like, you know what? This will be funny.
And it was. Yay. Yeah, up until this year, I had no seasonal allergies that I was aware of. The doctor said I may have had them, but they were never that bad, so I just thought, I'm a little stuffy today, right? But this is the first year that it was actively uncomfortable to the point that I thought I had clogged ears from like earwax or something. So I went to the doctor. She looks in and she's like, nope, you have swollen sinuses and ear tubes. And that's why everything sounds weird and feels uncomfortable. Here's 3 different medicines for you to start taking immediately.
And forever.
And forever. Yeah. I mean, some of them I can take just around the time, but other ones she's like, yeah, you're probably just going to want to take this all the time. Great. I'll add it to the ever growing list of medicines that I now have to take on a daily basis.
Up to lucky number 7.
You know, it's funny. I go to my in law's house and I open the cabinet and I see like the stack of different medications they have because they're in their 70s. And I'm like, that's not a thing that happens all at once, right? You just gradually add another bottle until eventually you're up to like 12 and you need one of those pill organizers. I am like one pill away from the pill organizer.
Yeah, you
Hooray.
you start looking at them and you're like, "Why am I taking a pill for menstrual cramps? I think something got mixed up and I just kinda went with it."
But on the other hand, I don't get those foot cramps I used to. Weird. Oh, my back knees all cleared up. Hooray.
Ugh. Alright, now we need to move on.
I'm so sorry. All right.
You
So
made it
today
gross.
we're talking about something completely unrelated, which is the state of IPv6 in 2023. You ready?
I have never been more ready.
Good. I don't think that's true, but we'll roll with it. So before we get into IPv6 in general, we'll do a little history on it, but I'm curious to know what your relationship is with IPv6. Have you worked with it in anger or just in a lab?
Or accidentally.
Or all three?
Mostly the third one.
Okay.
Um, as we'll see, the problem with IPv4 is that it's good enough and it's just stuck around. Not only is IPv6 far superior in like almost every way,
Yep.
it's longer. It makes
It's
it
longer. Yeah.
something that everybody hates.
Yes. IPv4 is just short enough to be human readable, like the way that phone numbers are. And IPv6 is decidedly not. Even with the way that you shorten addresses, it doesn't matter.
I argue that the shortening makes it worse.
It does, because now I have to like mentally compute how
Mhm.
many gaps there are.
And to the uninitiated, they look at that stuff and just like, nah, the heck with that.
I still remember the static IP addresses of the two domain controllers in my like second job, and I will never forget them. So that's what we're fighting against. That kind of just rolling forward with that inertia.
Right.
So listeners may be surprised to learn how old the IPv6 standard actually is. It was originally drafted by the Internet Engineering Task Force, also known as the IETF or the IFTF, all the way back in 1998. So we're talking the era of Janko jeans, frosted tips, and new metal still being somewhat new. Most of the world was still intensely offline, and those of us who weren't probably had dial up at best. I know I didn't get cable modem until 2001, I want to say.
Yeah, that tracks.
Yeah. And did I have Janko jeans, frosted tips, and listen to new metal? No comment. But the answer
You
is
talking
yes.
about then or are you talking about now?
Why choose? Well, I definitely don't have the frosted tips because I don't have enough hair to do that. But I think Jankos are making a comeback, which is horrifying. So anyway, there was a working group at the IETF who peered into their crystal ball in 98 and foresaw the eventual exhaustion of the public IPv4 address space. And so they began working on a new addressing scheme that would give us almost limitless addresses while also improving on some of the shortcomings of the IPv4 standard. If we fast forward almost 20 years to 2017, the IPv6 standard was officially ratified. That's right. Until 2017, it was still technically a draft standard. So, what the hell took them 20 years? Good question. And what does it mean to be ratified? More good questions. My, you are full of all these good questions. Have a cookie and shut up. Let's start with what IPv6 is in the first place for those who are unfamiliar or uncertain. So, IPv6, sometimes just called V6 because we're lazy, is the next and newest generation of the Internet Protocol. Its direct predecessor is IPv4, which might make you wonder, hey, what happened to V5 and V1 through 3? Great question. You're very smart.
Yay.
Then shut up.
Oh.
The short version is that all pre V4 versions were about splitting up the TCP and IP stack into their own protocols. Prior to V4, TCP and IP were one protocol together, and that was not a great idea. So they split them up. And
Right.
then,
If for no other reason than if we had left them together, then people would inevitably try to pronounce the acronym as TICPIP.
and that's just not helping
It's not
anybody.
good. No.
No. V5 was a failed attempt to support voice over IP at the protocol layer, which is a bad idea and probably why that version never made it out of draft. If you want the longer version of this story, I will link an article in the show notes that sort of runs down into the minutia of some of the versions. Not really worth getting into here. So, IPv4 is pretty much where we landed in 1981, and it has been chugging along ever since. There were other competing standards over the years, but really the rise of the internet sort of killed off most of these other protocols. Stuff like Apple Talk, IPX was out there. I'm sure you can think of a few other ones that fall under this category. Once the internet took over, it was all over. It's IPv4 or nothing.
DUN done.
I'm sure someone out there is screaming that Apple Talk was superior. First of all, shut up again. And
You
also,
are very mean today.
I am
It's
probably
probably the allergy medication.
I'm going to blame it on my allergies. Now I have an out for the next like 30, 40 years until,
Forever.
yes. When IPv4 was envisioned about 40 years ago, the internet was not really conceived of as it is today. And the idea that people would have, say, multiple devices on their person that all needed network addresses was a laughable concept at best. I think most people thought maybe some people might have a personal computer at home, but most likely not. And yet, that's the situation we find ourselves in today. Let's see, I have usually at least two devices on me that both have network connectivity, my watch and my phone. And if I'm carrying a laptop, we're up to three. If I have my Nintendo Switch, now we have four. And I'm sure if I have my what's that my tablet with me, okay, now we're up to five for
Yeah,
one
it really
person.
does not take long for people to start adding to that number.
Right.
Sometimes without even really noticing it.
And then you add on to that the prevalence of smart devices and Internet of Things that have sort of exploded into our households. And suddenly a /24 address space on your local router might not be enough. So, speaking of that address exhaustion problem, the IPv4 protocol uses a 32-bit address space, which has potentially 4.3 billion unique addresses to give out. That might seem like a lot, but unfortunately, when they were creating the standard, they just carved off large swaths of the address space for reasons like documentation, the link local space, and host networking. One of the most egregious is the use of the 127.0.0.0/8 space for host networking. That takes up 16 million addresses all on its own. Totally unusable for anything else. You know what we use that for? One thing. It's the loopback address.
Right.
So we have 16 million. Typically, systems use one. That seems smart.
Yeah,
In
of all
fairness,
the reserved addresses, that is definitely the one where you're just like, even in 1980, that should have been like, wait a minute.
they also reserved whole swaths of addresses for use in documentation. So if you wanted an example address, you would use one of these example documentation addresses, which no one uses, and they mostly lay dormant. But you can't use them for anything else because they're reserved in the standard for documentation.
Right.
Yeah. So, as IPv4 proliferated throughout the world, the public address space reserved for the internet was allocated to various countries, companies, and organizations. Not realizing that the resource would one day be extremely scarce, the IANA, the Internet Assigned Numbers Authority, handed out blocks of addresses in what we could say generous sizes to pretty much anyone who asked. and showed up at the door. So we have universities ending up with /8s because, sure, you asked, maybe even nicely. A little aside, when I worked at Villanova University, they were still in the process of moving over to private IP address space because it wasn't a /8, but it was something close to that. And they just used all these public IP addresses for their internal networking because why wouldn't you?
Because they had them.
Yeah. And then they wouldn't have to NAT, which was great. So the main challenge with IPv4 now is public address exhaustion. The last block of addresses was handed out, I want to say in 2012, to the ISPs. Now, that doesn't mean that it's actually been handed out to someone who's actively using those addresses. That took many more years, but the actual assignment of those blocks to ISPs and countries was basically completed 10 years ago. There's also other issues with the original implementation of IPv4 that are all improved upon by V6, but the main thing that was pushing V6 forward was the lack of available public address space in V4. Now, we probably would have seen mass adoption of V6 much, much sooner if it weren't for the happy accident that was private address space in V4 and the introduction of network address translation and port address translation. These two technologies allow a large number of nodes on one network to use a very small number of addresses in another network for communication. The most common implementation that you might already be aware of is having a NAT between your private home network and the internet. So, your wireless router or just your router is probably using a private IP address space of, let's say, 192.168.1.0/24. Can almost guarantee because that's the default almost every router comes with. But it only has a single public IP address that's assigned from your ISP. So the router basically does a mapping between an internal IP address and a particular port on the public IP address. And because there's 65,000 odd ports, that generally works.
Unless you have a lot of iPads.
And if you do somehow exceed that number of ports, which is a real thing, port exhaustion happens, especially in more active networks with lots of devices. You can bump it up and get another public IP address, and bam, you have 65,000 more potential ports to use. It also, the router's responsible for maintaining sessions between the internal network and the internet with those mappings, and it has timeouts assigned to sessions. So after a certain amount of time, it will end the session and free up that port for another device to use. So what that means is that NAT and PAT, despite the scarcity of public IP addresses, allowed organizations of all sizes to run massive internal networks with millions of nodes and only a small number of public IP addresses, say a Class C block or even smaller. And unless your company merged with another company that used the same private IP address ranges, which is a whole unbelievable headache we don't want to get into, um, unless you ran into that case, most of the time it was absolutely fine. If you did have two networks that use the same private IP address range, it was probably easier to burn everything down and go live in a cabin in the woods with your new best friend, Rodney the Cisco router.
Yeah, you can plant a whole field of spanning trees.
And watch them grow and tangle with each other. I remember the first time I crashed a network with spanning tree leaks.
It
It
was
was
never just the one time, though, was it?
no. I don't know why this is happening. What's link aggregation? I don't understand. Oh, before they put me in charge of data center networking, I probably should have passed the CCNA.
Or heard of it.
The what now? Yes. So IPv6 was created to solve many problems, but the main one was public IP address scarcity. And to solve the address crisis, IPv6 uses a 128-bit address space instead of 32-bit, when that is a frankly ridiculous number of addresses. I'll give you the number, but I don't think it helps with the scope and scale a lot. Just want. It's 3.4 times 10 to the 38 addresses.
Can you organize that by bunches of bananas?
No, it's not very like just that number is not helpful at all. Here's
It's
another way to think about it. There are roughly 2 to the 24th stars in the universe. Every single star could get an address and we'd have a ton left over. You could give every single grain of sand on Earth an IP address and still have some left over. It is an embarrassingly ludicrous number. So we were real worried about running out of V4 addresses, both in the private and public networks. If anybody is worried about running out of a V6 address space, it's safe to say they don't have a great grasp on math.
So the best way to put this is we have infinity addresses.
It's really close.
And just moving on forward.
I'm not going to say no one will ever need more than a 128-bit address space because people who say shit like that are inevitably wrong on a long enough time scale. But I feel pretty good saying for the next like 1,000 years, we're solid. So beyond this ridiculous size address space, what else is V6 meant to improve upon? Here's a quick rundown of the highlights. Multicasting. So this is the idea that you can send a single stream to multiple destinations. V6 has that built right into the spec. So you can just create a multicast address and send it to that, and all the devices listening on that address will get that stream. Super convenient. This is possible with V4, but it's an add on. It's not part of the base protocol. There's whole Cisco books dedicated to just setting up multicast, and it makes your eyes go crossed. V6 just has it built right into the addressing plan. Boom, you're done. So that's nice,
And
especially for
that's going to be a recurring theme, I feel.
the next one is stateless address auto configuration, also known as Slack, though I don't think anybody says that.
I hope not.
This removes the need to run DHCP or assign static IP addresses on your network for things to talk to each other, which is why many people end up using IPv6 without knowing it. Each interface generates a link local address on its own and then listens for router announcements to figure out how to send traffic outside of the local network segment. DHCP for V6 still exists when you want to be more stateful about things, but otherwise, it simplifies network addressing and makes renumbering a local network as simple as just updating the router advertisement. So it would maintain its link local address. It would just get a new address that it uses for sending traffic outside of the network.
So basically, it's an easy button.
Yes, V4 had something similar. The 169 address space was originally intended for this functionality, but no one ever sets it up. So it doesn't work. Next good one is IPsec. Fun fact, IPsec was originally part of the IPv6 spec and then backported into V4 because it was very necessary to have IPsec in V4. At one point, IPsec was a requirement for all V6 communications. So we could have had encryption by default. Not just encryption, but it also uh, identifies the sender and the receiver as well. So it's authentication and the encryption, which would be really nice. But that was a bit aggressive. Not everybody was on board. So the draft changed it to be optional. But IPsec is part of V6 and it requires using IKE v2 instead of V1, which is much more secure. Good job.
Progress.
V6 also simplifies routing, or to be more accurate, the packet header used for routing is much simpler. The actual routing and the efficiency is up for debate, but I'd prefer not to wade into those shark infested waters wearing a chum suit, so we'll move right on to the next one, which is the jumbogram.
Any
And I
relation to the Jumbotron?
sadly no, though a jumbotron could in theory use jumbograms.
Ooh,
Ooh,
I like it.
think about it. So I include this one just because the name is fun. You remember jumbo frames from like implementing iSCSI on VMware? That's how we're
Sadly, yes.
going. Are you sure you set the MTU size on all the devices in the path? Are you sure? For questionable network performance. So you could set it to 9,000 or more technically 9012 for the MTU. This is similar, but it's more about the total payload size that's being carried by the stream. So in IPv4, you were limited to 64 megabytes. IPv6 can handle about 4 gigabytes as a single payload. That's more.
Yeah, yeah. I'm doing the math in my head, and it's a lot. It's
Mhm.
like 5 times as much.
Yeah, so if you were streaming like 4K images to a Jumbotron, jumbograms might actually be super useful. Look at that. I did it. So, where is IPv6 today? Are people actually using it? Good question. And this time I'm not going to tell you to shut up because you're smart and you're pretty. Uh, so, V6 is overall a better protocol than V4. Hands down, it just is. But the thing about networking people is they're resistant to change, and not without good reason. In part because people love blaming the network when shit breaks.
It's one of my favorite things.
That's the first thing my kids do. As soon as their tablet doesn't work, like, Dad, the internet's broken.
I did the same thing when my refrigerator stopped working.
Yeah, you might have been right. And my crock pot, too. So, network admins try not to change things if nothing is currently broken. Even if it's only slightly broken, they still might not want to not change it because it could
Deal
be
with it.
more broken. Instead, they'll be like, I think it's the storage and move on. So, for them, switching to V6 seems like a big change that could probably break a lot of things. So, unless they have literally no other choice, they're not going to do it. In this case, we're talking about full move over to V6 or just doing dual stack V4 and V6. The actual chances of breaking stuff in dual stack are fairly low, but it's a change. They don't like change, and I don't blame them. The public internet is one place where they no longer have a choice. We're out of V4 addresses to allocate. The number of devices connecting to the internet has absolutely exploded. And ISPs don't want to be running mega nats if they don't have to, that's not the actual terminology. They call it something else, but it's essentially just these massive NAT boxes that have to do a lot of stateful routing, and it sucks for them. It's expensive to run, and they don't want to do it. And in some countries, they can't even get enough IPv4 addresses to use with their megaNAT. It's just not available. So you'll see a lot of ISPs, mobile carriers, and content storage solutions or delivery solutions turn to IPv6 for a solution. So if you're able to find it in your mobile devices, depending on which type of mobile device you have, I can guarantee that the IP address you're getting from your mobile carrier is a V6 address. I looked it up. My phone has 3 V6 addresses. One of
Just for
them being
fun.
just for fun. Well, one of them's the link local address, which allows it to talk to other devices on my local network, which is running IPv6, even though I never configured that. Magic. The other thing is that V6 has been fueled by the explosive growth of content and streaming on the internet. So CDNs like Cloudflare have V6 enabled by default, and it is the preferred protocol whenever it is available. Content providers like Netflix and YouTube also prefer V6. And if we're looking at a mobile first world, streaming using V6 is quickly becoming the majority. Adoption on private networks, however, has been a lot slower. It usually starts in the data center and then branches out from there. Although V6 has found some adoption in settings and settings that have, say, a ton of devices, like an industrial Internet of Things machinery shop or factory or something like that, where you're going to have potentially thousands of devices trying to stream telemetry, and they all need an address to do that.
Or, for example, the 15 million mini computers that make up modern, say, self driving cars.
Oh, another good point. Using V6 is a great use case for that. And they get all the benefits of easy local discovery and security on by default. Sounds good to me. So let's check out some of the recent numbers when it comes to adoption. Google keeps track of well, pretty much everything, including V6 traffic usage on the internet. As of January 2023, 43% of all traffic was using V6. And if the trend line is to be believed, and we assume somewhat linear growth, V6 should overtake V4 sometime next year in 2024. So that will mean the majority of traffic will be V6 on the internet. According to data from Akamai, Bahrain and India top out the countries adopting V6 at 100% and 67.5% respectively. Now, Bahrain's not very big, so I guess they somehow figured it out. India, however, is big and has a large population. So for them to already be at basically 2/3 of everyone using V6, it's a lot. And if you look at the adoption rates, many of the top countries arrived late to the whole distribution of IPv4 address space from IANA. And so they ended up with a lot less addresses than, say, I don't know, the United States. So, in effect, these late arrivals tend to adopt mobile at much higher rates to begin with and skip whole swaths of the tech journey that the US had to, let's say, wallow through. Now, I tried to find some data on the internal use of V6, and it was hard to come by. There's just not a lot of information out there. Anecdotally, the Ripe Labs V6 report indicates that V6 readiness and usage actually dropped in the last year. Now, the reason they say that and their theory behind it is that during the pandemic, people were ordered to stay at home, and a lot of those people at home were using V6 without knowing it. And then when people started coming back to the office last year, now they were working from the office. And so the amount of V4 traffic actually went up and V6 dropped a little bit. But if you look at the daily trend, it's actually interesting. You can see V4 traffic is higher during the workday in whatever country you're looking at. And then V6 traffic goes way up after the workday when everybody gets home and they fire up the old Netflix box and browse Facebook and live stream TikTokers or whatever you do at home. I'm not judging you, Chris. I mean, I'm judging a little bit. I saw your TikTok.
No, you didn't. Nobody did.
I have one view, and it's my mother. Oh, now let's turn our gaze over to the public clouds. How are they doing this whole V6 thing? Surely they've had plenty of notice and they built the cloud from the ground up. You'd think that they would be capable of running IPv6 only, right? No, no.
Mm.
So the short answer, as far as I can tell, looking through the documentation, is that the big three all allow you to spin up a VPC or a virtual network in dual stack mode, meaning run V4 and V6. But none of them allow you to run the entire network as V6 only. AWS announced general availability of V6 only subnets and EC2 instances, but the VPC they're in is still dual stacked. And that's probably because there are some services in AWS that don't support V6, meaning if your EC2 instances want to talk to that service, they're going to need a V4 address. So sorry. Over in the Azure world, things are a little more restrictive. Azure virtual machines need to be dual stacked. They cannot run in a V6 only mode. There's also a lack of support for V6 in a lot of their platform as a service components. And the irony here is that Microsoft itself has been quite the champion of V6 since the very beginning. I remember learning how to configure DHCP V6 on a domain controller for my MCSE back in 2003. Did you have a similar experience?
I don't remember that, but that doesn't mean that it didn't happen.
It may have been removed from some of the training materials later on, but at the time that I was studying for the tests, V6 was in there and you had to know at least the addressing scheme and how DHCP v6 worked at the time, which is actually different than how it works now. But we don't need to go down that rabbit hole. Also, fun fact, Microsoft Exchange, I think starting in 2013, was using v6, and it had to use v6. And fun fact, a lot of admins had this horrible habit of going into the TCP IP settings of their network cards and unchecking the v6 box because that made the card work faster, which first, no, it didn't. And second, it broke Exchange. That
Is
was,
that bad?
I mean, if you really hate your email, I guess it's
It
fine.
would it would explain why I got so many less calendar invites.
Yeah, and before anybody sends me feedback, it might have been Exchange 2010. I don't remember exactly which one it was. I just remember dealing with the problem when we would go to client sites to be like, our Exchange server's weird. And I'm like, yeah, because you disabled all these things that it uses. Anyway, uh, Azure unfortunately did not prioritize v6, so many of the services launched without support, and now they have to backport it in. And it really just never hits the top of the priority stack, if we're being honest. For Google Cloud's part, dual stack is also the flavor of the day, although it does appear that more of their PaaS services support v6 than Azure. So I guess what I'm saying is that if you need to use v6 or you'd prefer to use v6 in the cloud, go with AWS or GCP. Azure's going to catch up eventually, but it doesn't seem to be their priority because people are not paying to have v6. They're paying to have new features. So that's where all the development effort goes. Now, what about on-premises support? If you purchased network gear in the last 10 years, it probably supports v6. All modern operating systems also support v6. Most applications can also support it, especially if they don't dip too far down into the protocol stack. If they're staying at like layer 4, they're not even aware that v6 is in play. And if they dip into TCP, they still don't know. So it really has to be down at like layer 3 for it to start noticing something weird is going on.
So
So
like Nmap.
Nmap would be aware and should be.
One would hope.
Or if you're running like a hypervisor or a container platform or something else that's super low level, your mileage may vary, read the documentation, et cetera, et cetera. Kubernetes, for its part, fully supports IPv6 since 1.20, but you should also check the CNI that you choose to use with Kubernetes and make sure it also has that support. Calico, for example, not only supports v6, but also supports v6 in a non-dual stack setup. So if you want to run v6 only, you can do that with Calico. How about that?
How about it?
Mm-hmm. Now everybody's sitting out there going, what does this mean for me? It's all about me. Greedy little buggers. Well, as an IT pro who might need to dabble with networking on occasion, what does that mean for you? From an internal networking perspective, probably not a hell of a lot. The main use cases for moving to v6 on your private networks are one, supporting a massive number of devices. Two is simplified M&A with network rationalization, also known as no private network overlap, which is nice. Or
Very.
three, you're a content or service provider running infrastructure. And if that's the case, you already know who you are and you're probably already using v6. Otherwise, if you're on the private network side, you should be aware of v6 and have a loose idea of how it works, but chances are it's going to be another decade before your organization gets around to adopting it internally. Did someone say the same thing about a year ago? Yes, they did. Is it the year of VDI? Yes. Is low cost fusion 5 years away? Again, the answer is always yes.
What about the year of the Linux desktop?
The answer is yes.
Ooh,
Or
that's
very
exciting.
positive. Now, if you're, say, hosting websites or you have other public facing content, then v6 adoption is an absolute must. Remember that like 2/3 of all traffic from India is using v6? Yeah, you probably want to have a v6 compatible version of your website so that they can get the best performance. Can they still get to your website if it's served up through v4? Yes. Is the performance worse? Also, yes. Wow. Again, I'm so positive today. If you don't mind availing yourself of a CDN like Cloudflare, you pretty much switch to supporting V6 easily. Just let them do it for you. They sit on the front end, they handle all of the V6 traffic. And if it needs to go back to your V4 only website, it will pull the content and serve it through its endpoints. That's convenient. If you're hosting your website on a static site generator hoster of some kind, most of those also support
Is that the
V6.
technical term? The
That is
site generator hoster thing?
Yeah, like one of those things, like how Chaos Lever is hosted out of Azure Static Web Apps. Yeah, we could support V6. Unfortunately, it's not available for free because reasons? I don't know. You have to pay for like the enterprise grade tier, which annoys me to no end. If you're an organization and you want your own block of V6 addresses, you can go to Aaron. They're the ones who handle that sort of thing, and you can request one. If you meet their criteria, they'll issue one to you. Whee! Of course, you have to pay for it, and it's like $1,000 a year or something. What's actually much, much, much easier is just asking your ISP for a block of addresses. They've got plenty. Trust me. They'll probably hook you up with the /64 at the smallest, which is many times larger than the entire of the V4 address space.
Exponentially larger.
Yes, this is not a doubling. It's it's an exponential growth curve. So, yeah, you'll probably be okay with that number of addresses for like
Ever? Yeah.
now that's for the IT professional. What about the home user? For the average consumer, you're already using V6 on your mobile devices. As I mentioned before, just go in and look in wherever it is in your settings. For Android, it's under system settings. For iPhone, it's probably under something stupid with a bad name. For your home network, you're probably also using IPv6, and you may even have a public IPv6 address from your ISP. Verizon Fios is slowly rolling out V6, and other ISPs have already done so. Once V6 is enabled on the provider side, you'll have to update the configuration of your local router to get that external address through a router announcement. After which, it'll negotiate for a block of addresses to distribute via DHCP v6 internally. So your internal devices that support v6 will get that address, which is basically a public address, in addition to their link local address. And after that, they can talk to v6 services without a NAT. Yes, without a NAT.
Wee. And
Is
that's
that
the important part is that you never ever have to have two names for the same device in the networking perspective.
exactly
You use the IPv6 address everywhere.
everywhere, and it just works. It's magic. I mean, it doesn't just work, but there are other systems in place that let it work that you don't have to deal with, and that's the important part. Um, Now, rest assured, even though there's no NAT, some people get a little squirrely about it. They're like, "Oh, no. People can just talk to my devices because they have a public IP address." It doesn't work like that. Your router still acts as a firewall. It's still only going to use established sessions that started from inside your network. Now you just have the ability to publicly address stuff that's on your internal network if you want to. And that seems pretty useful. Now, if you do that, your ISP might protest because you're not using a business class service and they don't want you running a whole bunch of servers on your internal network if you're paying for the consumer grade internet. But that's between you and your ISP. Um, you'll still need a public IPv4 address and NATing for services on the internet that don't support V6. So you can't just go V6 only yet, but at least you can get the best performance available for sites and content that have turned V6 on. Do you have any questions or comments?
Oh, I'm sorry, I wasn't listening.
That's fair. Were you streaming something on TikTok?
I was watching a live stream of someone on TikTok watching Netflix via Twitch.
I'm not sure if that's a joke or not. That might be a real thing. I don't know. I don't think you can live stream on TikTok, actually. Isn't it just like
No,
short
you
videos?
can.
You
It's
can?
yeah. Oh yeah. I mean, I don't know. What? What was the question? Lightning round?
Lightning round.
ChatGPT continues to generate both positive and negative publicity.
Whee!
Couple of ChatGPT thingies came through the news this week. First, in a narrow test, it seems that ChatGPT has given better results than humans to people asking medical questions to a hospital help chat. This is good. And it's a great example of how and where to use this generative technology. It is narrowly focused, narrowly trained, relying only on vetted medical answers to previous similar questions, and crucially, when it responds, it doesn't get tired, thus, it doesn't get snippy, which is good.
Hmm.
Second, Europe appears to be adding legislation to force AI companies to publish a quote, sufficiently detailed summary, quote, of their sources. This is bad. So, ChatGPT is trained generally on billions upon billions of inputs, and we still only kind of understand how it comes to its conclusions. There is a real question as to whether or not AI like this can be properly programmed to give sources, which is bad.
Mm.
Finally, ChatGPT has been working to allow users to opt out of letting inputs be used for further training. It's in there now. Just a little simple little slider button, just a little guy in settings. It's literally the only setting under data management. And allegedly, if you flip that switch, all of your inputs don't go anywhere once your question gets answered, which is good.
Yay! I feel like we need to have another longer Chat GPT episode to dig into a lot of those and other things that are going on. So you now have an assignment for next week. Congratulations. The last version of Windows gets its last feature update. It was the summer of 2015. Uptown Funk was smoother than a fresh jar of Skippy. Christopher Lee shuffled off this mortal coil to join his friends in Tirasleen or Valhalla or Valinor or whatever it is in the Wheel of Time. And Windows 10 was released to wash the slate clean of Windows 8 and be the final version of Windows. At least that was the idea and what was in the marketing. Rather than having a major version upgrade every 4 or 5 years, Windows would instead receive regular feature updates every quarter. If you bought Windows 10, you would never have to buy another version, right? Well, no. Quarterly feature releases slipped several times and soon became semi annual releases. And then in October of 2021, Windows 11 dropped, thereby becoming a new version of the last version of Windows. What's weird is that if your PC was running Windows 10 and met the hardware specs, the upgrade to Windows 10 was free. Which begs the question, why give it a new version number? And the answer is, of course, money and marketing. Windows 10 is now at the end of its update road, with version 2022H2 being the final update, with no more feature releases to come. Security updates will keep flowing until Windows 10 hits end of service life in October 2025. But if you want new and cool features, switch to Linux or upgrade to Windows 10. Whatever. I'm not your dad. Or am I?
Yikes. Elon Musk proposes new Twitter feature micropayments to read news articles. Do I need to read it? I mean, that was a good summary.
Thanks. And go ahead. You wrote a whole thing.
This just in from the far too overworked section of the Chaos Lever news desk that covers Elon's bad ideas. Now he thinks that Twitter can be a news hosting aggregator that will entice people to buy access to articles on a per click basis. Let's see if we can hit all the reasons this is dumb in one quick go.
Let's go.
1. Elon has consistently and needlessly antagonized news outlets to the point that they're using Twitter less, and in some cases, not at all. 2. Twitter has fired most of their engineering staff, so it's unlikely that this feature would even be feasible, let alone stable. 3. Elon apparently has no idea that the micropayment model of news consumption has been tried over and over and over again, and nobody has been able to really make it work. 4. Elon has forgotten that people don't go to Twitter to read the articles. Studies going back as far as 2016 have consistently shown that less than 40% of people ever click the articles that they retweet about. They
Mhm.
just react to the headlines. Engadget, who listed out all of these fun, exciting things and will be linked in the show notes, reached out to Twitter for clarification about this business model and the technical capabilities of enacting this by the alleged May of 2023 release date, which, if you're doing the math at home, is now.
Yes.
But of course, you remember that Twitter doesn't have a press team anymore. All emails to the previously working press addresses return an auto reply poop emoji because Elon's hilarious.
I think my original reasoning of still stands. Quantum may be coming for your crypto, but not just yet. At the annual RSA conference, Adi Shamir and Clifford Cox participated in a panel making the argument that defending against quantum computers breaking encryption is a bit of a wild goose chase. The simple fact is, most encrypted communications are useless dreck, and decrypting it efficiently is not even in the realm of possibility with current quantum computers. Asked whether folks should adopt, quote, quantum safe cryptography for future communications, Ann Dames from IBM agreed that our fears are overhyped, but the longer and more secure the keys, the better. Now, there is a real computing cost involved with using longer keys, so that should be balanced against the sensitivity of your communications. Of much greater worry is protecting against insider threats, where all the encryption in the world won't save you if they already have the keys to the castle. Rather than tilting at quantum windmills that may or may not be there, organizations should instead invest their time and effort into protecting against more mundane and realistic threat vectors. Carl, in accounting.
That guy knows everything.
Damn it, Carl.
Microsoft pivots, announces support for a right to repair bill. Now, the idea that you should, I don't know, be able to fix the devices you paid for, also known as the right to repair, is, for some reason, a very controversial idea at the state and federal level. Wait, no, I got that wrong. It's actually a super known reason. Quote, despite dozens of state legislatures taking up right to repair bills in recent years, very few of those bills have passed due to staunch opposition from device makers and the trade associations representing them, unquote.
Mm-hmm.
This used to include Microsoft. Recently, however, they have been changing their tune. The Fair Repair Act, a Washington state bill that attempted to force this reasonable request to be possible, died in committee, but not before Microsoft was able to make a public statement supporting it. This has been an evolving position for Microsoft, with them trying to be, quote, part of the conversation rather than outside it since 2021. This also included efforts to open up their own device repairs, a first for a major manufacturer.
Mm-hmm.
Tough to say if this pivot is simply a cynical shot at Apple, bandwagoning because they see the writing on the wall, or a sincere belief in what should be an uncontroversial concept.
Why choose? Advertising company Google turns a profit on something that's not advertising. Shit.
What?
Does that mean I have to stop calling them advertising company Google? Wait, what's that? 78% of their revenue and 99% of their net income is still from ads? Oh, good. Never mind. For Q1 2023, Google Cloud brought in $7.4 billion in revenue, an increase of 28% year over year. More impressive is that they had operating income of $191 million. That's the very first time Google Cloud has ever been profitable. Now, that's not net income, it's operating income, so it's kind of dicey, but still profitable. I should point out that there is a vague corporate costs unallocated line that had $3.3 billion in losses. If I wanted to make my cloud seem like it was finally in the black, I might shove some of that cost into a poorly defined category that serves as a catch all for whatever I don't want to include in cloud costs. I'm not saying that's what's happening here. I'm just saying some of that cost is paying out severances, and surely some of those people laid off worked for Google Cloud. That's it. I'm not saying anything else. Heavily implying, of course. Saying, no, never. Well, hey, thanks for listening or something. I guess you found it worthwhile enough if you made it all the way to the end. So, congratulations to you, friend. You accomplished something today. Now you can spend the rest of the day avoiding making that doctor's appointment because who knows what weird maladies you've developed in the last year. You don't, and you don't want to. You've earned it. You can find me or Chris on Twitter at Ned1313 and at Hainer80 respectively, or follow the show at chaos_lever if that's the kind of thing you're into. Show notes and the sign up for our newsletter are at chaoslever.com if you like reading things. We'll be back next week to see what fresh hell is upon us. Ta-ta for now. That bill was called the Fair Repair Act, and I think because it rhymes, it's a good bill. That's how it works, right?
I mean, 1 million voters in Washington that didn't get a chance to vote on this can't be wrong.
Democracy!